Hello everyone, welcome to Genius channel. We'll see some previous year maths questions for NDA. Okay, so see the question number 9. Question number 9. If A is equal to 0, 1, 1, 0, then the matrix A is a singular matrix, an involutory matrix, nilpotent matrix, idempotent matrix. Okay, all of you try this. Just check whether it is singular matrix, involutory matrix, nilpotent matrix, idempotent matrix. Okay, so for solving this question, you need to know what is the meaning of these types of matrices. What is singular, what is involutory, what is nilpotent, what is idempotent, etc. Okay, so first of all, I'll explain that, then you identify what kind of matrix is this. Okay, so first, please all of you write singular matrix. Singular matrix. So what is a singular matrix? Singular matrix is a matrix whose determinant is 0. Okay, singular matrix is a matrix. It is a square matrix. Singular matrix is a square matrix whose determinant is 0. Please note down. Singular matrix is a square matrix. This is a square matrix whose determinant is 0. Determinant is 0. If determinant is not equal to 0, then it is non-singular. Okay. So for checking a matrix whether it is singular or non-singular, you have to just take the determinant and see whether determinant is 0 or not. Next is involutory matrix. Involutory matrix. Involutory matrix. So this involutory matrix are those terms which are not mentioned in your NCERT textbook. So when you see that in the question paper, you may be seeing that for the first time. So if that again repeats, so this is a previous year question. It is already asked, but there's a possibility that they can again ask. Okay, so what is an involutory matrix? Involutory matrix is a matrix which when multiplied by itself yields identity matrix. It is a square matrix. Write down, it is a square matrix which when multiplied by itself, yields identity matrix. Okay, so involutory matrix is a square matrix which when multiplied by itself yields identity matrix. Now see the question given for us. The question given for us was with a matrix 0, 1, 1, 0. This is the matrix given to us. Okay, now we have to see which is this matrix belonging to, whether this is singular, involutory, idempotent or nilpotent. Okay, so that I'll see remaining. First of all, we'll see whether this is singular or not. So take the determinant. For taking singular, we have to take the determinant. Determinant of A is 0 into 0 minus 1 into 1. So that is 0 minus 1, that is minus 1. So this is not a singular matrix because it is not, determinant is not 0. So it is non-singular. Non-singular. So first option is not correct. First option is not correct. Next, let's see. Let's see whether This is involutory matrix. Involutory matrix. Okay. Involutory matrix, how can we check? And matrix, involutory matrix means if we multiply the matrix by itself, you have to get identity matrix. So let's see that. So matrix given is 0, 1, 1, 0. Then multiply that again with that itself. So what you're getting? 0 into 1, 0, 0 into 0, 0 plus 1 into 1, 1. So 0 into 1, 0 plus 1 into 0, 0. Then 1 into 0, 0 plus 0 into 1, 0. 1 into 1, 1 plus 0 into 0, 0. So see here, A into A is equal to I. So this is an, it is an involutory matrix. Involutory matrix. Okay. So this is an involutory matrix. So our answer is option B for this particular question. So I'll show the question again. So the question was whether this matrix is singular. So it is not singular. We have already shown. Then it is involutory that we got. So it is involutory. Answer is option B. Answer is option B. But here I'm just explaining you what is nilpotent matrix and idempotent matrix. So this question is over because we got the answer as involutory matrix. But you have to check, understand what is nilpotent and idempotent. Okay, so here the answer is over. Answer is option B. I'll just show you what is nilpotent matrix and idempotent matrix. Please write down that. Please write down nilpotent matrix. Nilpotent matrix. Nilpotent matrix. Okay, write down nilpotent matrix is a square matrix. It is a square matrix. Square matrix for which there exists a non-negative integer k, a non-negative integer k, such that a raised to k is a zero matrix. A raised to k is a zero matrix. The smallest such an integer, k is called degree or index of A. Degree or index of A. Degree or index of A. So understand, if I have a matrix, then I am doing its multiplication with itself. I am doing that k times. I am multiplying this matrix with itself, then again doing that, and again repeatedly doing that. Then when I get this multiplication as 0, after sometimes I get this as 0. Then if suppose I am getting this at, when I multiply that 4 times, I am getting a 0 matrix. Then that such a matrix is called as nilpotent matrix. Such a matrix is called as nilpotent matrix. And for what value, for how many times I am multiplying to get it as 0, that is known as nilpotent, that is known as its degree. I'll show you one example, then you will understand more clearly. Write one example. A is equal to 0, 1, 0, 0, 0, 1, 0, 0, 0. if I have a matrix A like this, then please do A square, all of you. A square means multiply one time. Multiply. Then you will be getting it as 0, 0, 1, 0, 0, 0, 0, 0, 0. But this is not a zero matrix. This is not a zero matrix. Now, again, do multiplication one more time. That is A square into A. That is, you are going to do A cube. Then notice that 0, 0, 1, 0, 0, 0. A square, I already have the answer. 0, 0, 0 into one more time A. 0, 1, 0, 0, 0, 1, 0, 0, 0. So when you multiply this, you are getting the answer as 0, 0, 0, 0, 0, 0, 0, 0, 0. Now listen. So what I got A cube as zero matrix. A cube as zero matrix, isn't it? So A square, what's not zero matrix? A cube I got as zero matrix. Then I can say A is a nilpotent matrix. Nilpotent matrix. A is a nilpotent matrix. And what is the index? Index is 3. Index is 3. Why? Because when I multiply that 3 times, that is cube. When I do the cube, I'm getting zero matrix. Understood? Okay. So that is nilpotent matrix. Now write the definition for idempotent matrix also. Idempotent matrix. Idempotent matrix. Idempotent matrix. Write the definition. Idempotent matrix is a matrix. Idempotent matrix is a matrix which when multiplied by itself yields itself. Idempotent matrix is a matrix which when multiplied by itself yields itself. So what is that meaning? So I have a matrix A, for example. Then I am doing multiplying it again with itself. Then I am getting A itself. Then it is an idempotent matrix. Okay, so if you want, write one example. The matrix A is equal to 4 minus 1, 12 minus 3. Try A square or multiply that with itself, A square. That means I am multiplying this with self. So when I multiply 4 into 4, 16 plus minus 1 into 12. That is 16 minus 12, you get 4. 4 into minus 1, minus 4 plus 3. So that is minus 1. Then 12 into 4, 48 minus 12 into 4, 48 plus 3 into 12 minus 3 into 12, so 36. So 48 minus 36, you'll get again 12. Then 12 into minus 1 minus 12 plus 9, that is minus 3. See, I got A square is equal to A. A square is equal to A itself. So this is an idempotent matrix. This is an idempotent matrix. Idempotent matrix. Okay. So that's all about 4 kinds of matrix that is mentioned in the question paper. Okay. So we'll continue to do the question paper. So here the ninth question where we were discussing, and the answer is found to be answer B, option B. Okay, then let's go to the next question from this question paper. So we have already discussed 10, 14, 15 and all in the previous video. So now come to the question number 16. Question number 16. Consider the following for the next two items that follow. Question number 16. Consider the following for the next two items that follow. In a school, all the students play at least one of three indoor games: chess, carom, table tennis. 60 play chess, 50 play tennis, 48 play carom, 12 plays chess and carom, 15 play carom and table tennis, 20 play table tennis and chess. Now, you have to find what can be the minimum number of students in the school. Minimum number of students in the school. And there is one more sub question. One more sub question. What is the maximum number of students in the school? Minimum number of students and maximum number of students you have to find out. So I'll show the question again. You have to find out minimum number of students and maximum number of students in the school. Okay. So please try that. All of you try and comment your answers. I want you to try those things. Okay. We got the answer. So first of all, I'll write what all things are given in the question. Say there are chess playing students. How many? N of C. I am writing chess as C. 60. Number of students playing table tennis. I am taking as N of T. That is 50. So number of students playing chess 60. The number of table tennis playing students 50. Number of caroms playing. I'm writing caroms at P. Suppose I'm taking caroms as P. So that is 48. Then 12 play caroms and chess. Carom and chess. So chess C, carom P I have taken. So those students playing both carom and chess intersection, isn't it? So that is given as 12. Then number of students playing carom and table tennis. So that is 15. Number of students playing tennis and chess. That is 20. You have to find out minimum number of students. First we will see minimum number of students in the school. So they are already saying all students at least plays any of the games. All the students play at least one of the three indoor games. One of the three indoor games they'll play. One of the three indoor games they'll play. So nobody is there that who don't play any game. So what is the formula? N of, you have to find union, isn't it? C union T union P. that is equal to n of C plus n of T plus n of P minus n of C intersection P minus n of C intersection T minus n of P intersection T plus n of C intersection T intersection P. This is the formula we are having. This is the formula we are having. N of C intersection T intersection T union P union T union C union T union P is equal to N of C plus N of T plus N of P minus N of individual intersection C intersection P C intersection T P intersection T C intersection T intersection P. Now, minimum number of students. Minimum number of students means from this intersection part should be 0. Minimum means this addition part, this sum part, this part should be 0. The students playing all three together, that means play who plays three games together. Okay, that should be 0. So minimum, I'm writing that remaining part here. Minimum means what is 0? N of C intersection T intersection P. That is to be 0. So what is the minimum number of students? C union T union P is equal to 60 plus 50 plus 48 minus 12 minus 15 minus 20. So do that. 110 plus 48, 158 minus, do this subtraction also. So you will get it as, because C intersection T intersection P, you took as 0 for minimum. So you get the answer as 111. 111. 111. Option B is the correct answer. Option B is the correct answer. Okay. Now see the remaining part of this question. Remaining part of this question, you have to find maximum. Next question is finding maximum. Maximum number of students. So I'm clearing this part. So the answer for the 16th question was option B. Okay. Now the next sub question I am going to show you. Next sub question. Maximum number of students in the school. Maximum number of students in the school. So you have to find N of C union T union P. The same equation I have to use. Then I need maximum number of students. Maximum number of students means here N of C, we have N of C 60, N of T 50, N of P, caroms I took as P. So I'm just, you can take ABC, anything is okay. Then I have C intersection T as 12, C intersection, isn't it? C intersection, chess and table tennis, that is 12, no? Chess and table tennis 20, chess and carom 12, carom is P, carom and table tennis, that is 15. Now I need maximum number of students. Maximum number of students means I have to take N of A, C intersection T intersection P. C intersection T intersection P, that is 12. That is 12. What is 12? 12 is coming from here. See, or from all these intersections, see from all these three intersections, take the minimum. Take the minimum. Understood? From all these individual intersections, take the minimum and you take that as in C intersection, D intersection, B. Now what will be my formula? 60 plus 50 plus 48 minus 20 minus 12 minus 15 plus this 12. Understood? So maximum number of students means you from this individual intersection you take the minimum value, add that in that equation. This is our original equation we have written in the previous question. N of C plus N of T plus N of P minus individual intersections, then plus total intersection. So that should be taken as minimum of this three intersections. So once you solve this, you get the answer as 123. Option B. Again, B is the answer 123. 123. Okay. So that's about that question. Now go to the question number 20. Go to the question number 20. From 6 programmers and 4 typists, an office wants to recruit 5 people. What is the number of ways this can be done so as to recruit at least 1 typist? At least 1 typist should be there. Minimum 1 typist, and they want to recruit from 6 programmers and 4 typists. 1 typist is must, at least. Minimum 1 typist. More than 1 also fine. But they need programmer as well as typist in the 5 people. So do this, how many ways we can do? See, 6 programmers and 4 typists. 1 typist is a must, at least 1 should be there. So from 6 can be 4 programmers and 4 typists, it can be 1 typist. Or from 6 it can be 3 programmers and from 4 typists it can be 2 typists. Totally there should be 5. There should be 5. Or from 6 it can be 2 here. From 4 it can be 3 typists. From 6 programmers there can be 1 programmer taken, and from 4 typists there can be 4 typists taken. So totally 5. So these are the possible ways. So now convert that into equation. From 6 4 means 6 4, isn't it? So 6C4 4C1. 6C4 4C1, or means plus 6C3 4C2, or 6C2 4C3, or 6C1 4C4. So do this. 6C4, that is 4 into 15 plus 6 into 20 plus 4 into 15 plus 1 into 6. So when you do that, you will get the answer as 246. Answer as 246. Option C. Option C is the correct answer. Option C is the correct answer. Okay, so see you in the next class. Thank you, everyone.